All right, welcome to part 2 of our lesson on Ch6-2, dealing with exponential functions. So I've gone ahead and put this at the top of my page just so that we have that as a visual reference point as we work through our problems. We talked about how A represents our initial amount, and B represents the constant ratio by which we're continually multiplying as many times as our exponent tells us to. So in part B, we're going to do some graphing. And these are just going to be some quick sketches. We're going to identify some key features of each graph and be able to just make a quick sketch. So in our first example, we have f of x equals 2 to the x. Now, as you look at that, you think, there's only one number, and here I see that there needs to be 2. So you kind of want to think about there being an invisible multiplier out front of multiplication by 1. And I hope that shows up red to you guys. That's a red 1 times 2 to the x. So that's going to tell us our A and our B values. So in order to graph, we need some points. And in order to have some points, we're going to need to create a table of values. And our table of values typically has some negatives, always has 0, and then some positives. So we'll use some easy numbers here. So -2 to +2. And I'm going to start off with the easiest spot, which is going to be this 0. And the reason I start at 0 is because if we think back to our first section of our notes, that 0 was always next to our initial amount. Whatever was here was always with an initial amount that we made our A value when we wrote our equations. And so this is our A value up here of 1. And so you can automatically say, oh, I know that is 1. Now, if we thought about that mathematically and said, if I plugged in 0 right here, I would say order of operations says to do exponents first. So 2 to the 0 is 1. And so if we have 2 to the 0 is 1, there'd be a 1 right here, and then 1 times 1 order of operations would give us 1 as well there. So that's nice and easy. We now have our very first point. Excuse me, I'm still sick. We're going to do the same thing with each of these other points. We're going to plug in 1. So we might say 2 to the first. 2 to the first means 2 only one time, so that'd be 2. And 2 times 1 is 2. We'll continue on. 2 to the second power. 2 squared is 4. And we really only don't even need to use that times 1. That was more just to get our A value. So we'll say 2 squared is 4. Now, for these other values up here, we can think about this in terms of plugging in -1, plugging in -2. Some of you might know that a negative exponent, 2 to the negative first, is going to cause this term to flip over. Some of you may actually want to type in to your calculator 2 raised to the negative first power. You may even realize that our values are getting cut in half. By 2 is 2, divided by 2 is 1, divided by 2 is a half. You can even say 0.5 if you want. And cut in half again is a fourth, or you can even say 0.25 if you want. So however you'd like to get those, you can think about it mathematically, you can think about following the pattern in the column, or you can think about typing values in. So the next thing we're going to do is we're going to make a little sketch. And you'll make note that we have no negative values here, so we really only need the top 2 quadrants. So we label out our x-axis and our y-axis. We're just going to have 1 and 2, -1 and -2, because that's all that we did in our table. And really the highest value we need here is 4. So we'll go 1, 2, 3, 4, and we'll label those out. Again, we're just making a quick little sketch. So following along with our points, I'm going to start with that initial value. That's 0, 1. And what would another name for this point be that we just graphed right here? This point right here is called the y-intercept. And then we're going to graph our other points. So 1, 2, 2, 4, -1, a half. We'll have to do some what I call eyeballing, about halfway between where 0 and 1 would be. Same thing for our next one, about halfway between a half and 0 would be a fourth. And so we can see that these exponential functions are going to look like a curve. And so the one thing that I want you to be able to do from the graph after you've drawn it is to identify some key features. We're going to have 4 key features that we want to identify. And the first one is going to be the y-intercept. And we actually already talked about that a little bit. We talked about the y-intercept when we graphed that very first point. So that's 0, comma. It's always going to be 0, comma, and 1. Notice it's 0, comma, that number right there. The next thing was the domain. How far to the left and how far to the right are we allowed to go? It appears like we're able to go to the left forever and to the right forever. So we could say all real numbers. Is going to be the range. And we see that we didn't need the bottom two quadrants. Since we don't need the bottom two quadrants, we only need things that are greater than the x-axis, and the x-axis is actually a y equals line. So we're going to say y such that y is greater than 0. And that's because we can't go down into these negatives down here. We have to stay in the positives. The last thing I want you to identify is what's called an asymptote. An asymptote is just an imaginary line that the graph can never cross or touch. And since this curve can never cross or touch this x-axis, kind of like right in there, and that's because half of a fourth is an eighth and half of an eighth is a 16th, we're never going to get below 0 because we always have something to cut in half. And so an asymptote is something we can never cross. Ooh, I'm going to spell that wrong. Ooh, never, we're going to mess it up, dress it up. Never cross or touch. Our asymptote here would be the x-axis, which has an equation of y equals 0. Okay, that's kind of the newest piece for us. All right, so I want you to really think about what we just did. I'm going to stop the video and start again for number 2 and be able to work through number 2 a little quicker than we did number 1.